Imagine stepping back, way back, 430,000 years, not to some empty landscape, but to ancient Greece, just teeming with life. Picture these, like, colossal elephants roaming around, much bigger than anything alive today. Now, here's the really cool part. Imagine our ancient ancestors taking on these giants, not with huge spears or anything, but with these surprisingly small yet incredibly effective stone tools. Today we're doing a deep dive into Marathousa 1. It's an archaeological site in the Greek Megalopolis Basin, and it's not just another dig. There's this brand new study just out in PLS1 by an international team led from the University of Tübingen. It sheds light on one of the oldest known spots for animal processing, like butchery, in the southern Balkans. So our mission today, to unpack the sheer ingenuity of these Middle Pleistocene hominins, to understand their, sophisticated approach to tech and what it tells us about how they adapted. Get ready for a real aha moment, because it kind of reshapes how you might think about prehistoric capabilities. It turns out, as the researchers say, small tools are not a sign of simplistic technology. On the contrary, they reflect a well-thought-out adaptation. All right, let's zoom in on this, Marathousa 1. Where exactly are we talking about in Greece?
Okay, so Marathousa 1 is what we call an open-air site. It's located in the Megalopolis region, right in the central Peloponnese part of Greece.
Right.
And it's a really remarkable spot. It gives us a direct look into this incredibly ancient past.
And how ancient? What's the time frame here?
We're looking at around 430,000 years old, give or take, of course.
Wow.
Yeah, it's currently the oldest known archaeological site in Greece. It was found just over 10 years ago, between 2012 and 2013.
Okay.
And its significance is huge because it's a really rare chance to study human behavior in southern Europe during the Middle Pleistocene. We just don't have a lot of direct evidence from this specific period and region.
Right, a rare window. So 430,000 years ago, what was the place actually like? You mentioned resource-rich. How did that environment shape things for these hominins?
Well, the Megalopolis Basin back then was a really prime spot. The key thing was a large paleo-lake, an ancient lake.
Okay.
This meant a constant supply of fresh water, even during colder times. It basically acted as a refugium, a kind of sanctuary.
Refuge.
For an incredible range of large animals. We're talking extinct, straight-tusked elephants, Paleoloxodon antiquus, huge animals.
Wow.
Also ancient hippos, different kinds of deer, bison. And besides the big herbivores, there were carnivores, even primates, macaques.
So a really vibrant ecosystem.
Absolutely. Temperate landscape, diverse plants, trees, aquatic stuff near the lake, just packed with resources these hominins could use.
Amazing. And it's right there, in the middle of all that ancient life, that we find this clear evidence of our ancestors interacting directly with, well, especially with the biggest creatures around.
Exactly. That's one of the core findings. Alongside the stone tools, the researchers found the remains of that extinct straight-tusked elephant Palaeoloxodon.
Okay.
And what's really compelling is that the bones, the elephant bones themselves, show clear-cut marks and impact marks.
So not just found nearby, but actually worked on?
Precisely. It's direct evidence. Hominins were dismembering these animals, processing them. It's a tangible link between the tools and the megafauna.
Which brings us to, well, a pretty huge question. How on earth did they process an animal that massive? An elephant? That must have been just a monumental task.
It really must have been. The study suggests they probably viewed these elephants as like an organic quarry.
An organic quarry, meaning?
Meaning not just a source of meat, though the cut marks definitely show they were eating them, but also a mobile supplier of raw materials.
Ah, okay, like bone, hide.
Exactly. And there's specific evidence for that, what the researchers call anthropogenic modification. Human-made changes to the bones.
Such as?
Well, they found things like a bone slake that was intentionally shaped into a tool with a serrated edge like a saw.
Wow.
And also a bone percussor, basically a hammer tool made from bone.
So they weren't just eating the elephants, they were using their remains to make more tools.
Yes, exactly. It shows this foresight, this planning that goes beyond just getting the next meal. It's about maximizing absolutely everything you can get from such a huge resource.
So let's talk about the tools they were using for this massive job. When you think elephant butchery, you probably picture, I don't know, giant hand axes or something heavy duty.
And, well, that's where the big surprise, the real aha moment kicks in with Marathousa 1.
Okay.
The evidence points to what's called a small tool component in their toolkit, their lithic industry. We are talking about artifacts generally smaller than 40 millimeters.
40 millimeters? That's tiny. Like what, an inch and a half?
Roughly, yes. Thumbnail size up to maybe a large postage stamp.
Yeah.
And get this, the average size for a basic flake, just struck off a core, was about 20 millimeters.
20.
And for a retouched tool, one they sharpened or shaped more deliberately, around 26 millimeters.
That's incredible.
And here's a real kicker. 71%, nearly 3/4 of all the stone artifacts they found, were chips and microchips, less than 15 millimeters across.
15 millimeters. So you're telling me they're taking down and processing elephants with tools you could literally pinch between two fingers?
That's what the evidence strongly suggests. It's not primitive at all. It actually points to incredible precision, efficiency, and a really deep understanding of the materials they were working with.
Wow. Okay, my mental image is completely changed. What were these tiny, potent tools made from?
The primary material was local radiolite. It's a very hard, silica-rich rock, good for making sharp, durable edges.
Okay.
But they also used some limestone, flint, and quartz found nearby.
Was the radiolite consistent?
Actually, no. The quality could vary quite a bit.
Yeah.
And that suggests they were probably testing the raw materials right at the source, where they picked up the pebbles or chunks before carrying them back to the site.
Smart, selective.
It indicates a really informed approach to resources, not just grabbing any rock.
So, given these materials, how did they actually make the tools? What techniques were they using to get such effective implements from small pieces?
They use a really clever combination of techniques. It shows this great adaptability. One main method was freehand striking.
Okay, what's that involve?
That's where you hold the core, the piece of stone you're working on, in one hand and hit it directly with a hammerstone, maybe another rock, in the other hand.
Right.
This was mainly for creating those small, sharp flakes. It's probably faster, maybe a bit more effective for just getting a sharp edge quickly.
Okay, and the other technique?
The second was bipolar striking. This is a bit different. You place the core on a hard surface, like a flat rock acting as an anvil,
Mm-hmm.
and then you strike the core from above with your hammerstone. So the force goes through the core and kind of reflects back up from the anvil.
Ah, okay. Why use that method?
It's particularly good for getting flakes off small or kind of awkwardly shaped cores, like rounded pebbles that don't have a nice flat surface to hit. It lets you make the absolute most efficient use of the raw material.
So it's simple, but effective.
Exactly. Someone described it as simple but not simplistic. You still need to know what you're doing, understand the physics of how the stone will break.
So they're blending these methods, almost tailoring the technique to the stone and what they needed.
That's exactly right. It points to this really flexible technological strategy. The researchers actually did detailed analysis, like statistical comparisons of the flakes found at the site with flakes made experimentally using both techniques.
And what did that show?
It showed that most of the flakes looked like they were made using freehand striking. But the bipolar method was clearly important for dealing with those small or tricky pebbles, especially maybe for testing them out initially or right at the end when a core was almost used up.
Got it, maximizing the resource.
Totally. It demonstrates a really functional, effective level of technical skill for hominins this far back.
So beyond the basic sharp flakes, what else were they making from these small bits of stone? Any more specialized tools?
Yes, definitely. They also made what archaeologists call reworked tools. They'd take a flake and modify it further, like
Right.
scrapers, maybe for working hides, toothed tools, which could have been used for sawing or shredding plant material or connective tissue, even small pointed tools that might have functioned as drills or perforators.
Yep.
And one really interesting find was naturally backed knives. These are flakes where one edge is naturally thick or blunt, making it easy and safe to hold.
Ah, like a built-in handle.
Kind of, yeah. And the opposite edge is naturally sharp, perfect for cutting. They were also clever enough to sometimes turn the cores themselves, once they're too small to get more flakes off, into usable tools.
Resourceful.
Very.
Yeah.
And what's really fascinating is how clearly these small tools were tailored to the specific properties of that local radiolite, how it fractures, its quality. It really challenges that old idea that bigger flakes were always better or more advanced.
Right.
Because experiments actually showed these small flakes were surprisingly efficient for butchering large animals like elephants. Precision over brute force, maybe.
Okay, that leads to a really crucial question then. How are they actually using these tiny tools? Were they, like, attaching them to handles, hafting them, or just holding them directly?
Yeah, that's a really important point, the whole hafting versus handheld debate.
Because hafting gives you more leverage, better grip, maybe?
It can. Absolutely. Especially for tasks like scraping hides where things might get slippery or you need more force. But what's interesting is the experimental work done specifically for this study.
What did they do?
They actually replicated the Marathousa 1 radiolorite flakes and tried butchering large animals. Not elephants, obviously, but analogous tasks.
Yeah.
And they found that these small flakes could be held very effectively directly in the hand for butchery tasks. You could grip them securely, say, between your thumb and forefinger, and achieve remarkable precision and control.
So they were designed well enough to just hold ergonomic, basically?
Exactly. The term used is excellent prehension ergonomics. They just fit well in the hand for the intended purpose.
Huh.
And some of the tools found at Marathousa 1 even seem to have features like maybe a thinned area or an area left unmodified that look like they were intentionally designed to make them easier to hold directly without needing a handle.
So direct hand use was a deliberate strategy.
It seems so. And it fits with a broader pattern we see in other Middle Pleistocene small tool industries elsewhere. Direct handheld use was clearly a viable and widely adopted option. It tells us they were focused on immediate, practical functionality.
Okay, let's zoom out a bit then. How does Marathousa 1 fit into the bigger picture across Eurasia? Was this small tool approach something unique happening in Greece, or was it more common?
That's a great question. Historically, research on the lower Paleolithic, this very early period, often focused heavily on the big tools like hand axes. Small tool industries sometimes got overlooked.
Right.
Marathousa 1 is really significant because it's currently the only known Middle Pleistocene site in Greece with this distinct small tool focus. It contrasts sharply with other Greek sites from roughly similar periods like Rhoda of Nydia, which are famous for their large cutting tools.
So it stands out in Greece, but elsewhere.
Elsewhere in Europe, looking at sites dated roughly between, say, 600,000, 300,000 years ago, we see some really interesting connections, technological similarities.
Thereabouts.
Well, in Central and Eastern Europe, for example. Sites in Poland, like Trzebnica or Rusko, show this trend towards making smaller tools, often heavily reshaped or retouched. In Hungary, at Würzenzluch, they found naturally backed knives made from jasper and radiolorite, very similar to Marathousa 1.
Okay, Germany.
Germany, too.
Right.
Sites like Bilzingsleben and Schöningen, famous for the wooden spears, also have elephant remains associated with small tool industries, often made on sort of natural chunks or flakes.
And Italy. I know there are important early sites there.
Yes, Italy has numerous Middle Pleistocene sites, Isernia La Pineta, Fontana Ranuccio, La Polidrada di Canibio, among others, where these small tool industries are frequently found alongside elephant remains.
So a real pattern.
A definite pattern. They often show similar characteristics. Tools aren't highly standardized, they're specialized retouching, and they often use both that freehand and the bipolar striking technique we talked about.
So this wasn't just a Greek thing or an isolated invention. It was part of a larger technological landscape across Europe, often linked to processing these huge animals. Does this tell us anything about how early humans spread dispersals?
It potentially does.
Hmm.
There's a quite compelling theory or hypothesis suggesting that hominins who were adept at using these kinds of small tool industries might have been among the first groups to successfully migrate out of Africa,
Oh, so?
potentially moving through the Near East corridor. There are sites in that region, places like Bizat Ruhama in Israel, Gesher Benat Yaakov, Kazim Cave, that show somewhat similar adaptable tool strategies dating back very early.
Suggesting maybe this flexible toolkit was key to moving into new environments.
It could be. It suggests a shared, efficient technological system that allowed them to thrive in different settings, exploit different resources, including these massive animals.
But you're saying it wasn't all identical.
Oh, absolutely not.
Yeah.
It's crucial to understand these small tool industries weren't some kind of rigid, monolithic tradition. They varied quite a bit, depending on the local rocks available, the specific tasks people needed tools for, the environmental context.
Right.
And that's where Marathousa 1 really shines. You have this specific, resource-rich, lakeside environment, the availability of radiolorite, and this smart strategic mix of bipolar and freehand napping. It highlights a unique, context-specific adaptation, a structured yet flexible technological strategy, as the researchers put it.
It really paints a picture of incredible adaptability. So wrapping this up, the discovery at Marathousa 1 fundamentally shows that 430,000 years ago, these hominins weren't just, scraping by, they were strategically adapting.
Absolutely. Combining different ways to make tools,
Mhm.
carefully choosing materials.
All to process immense animals with these, surprisingly tiny tools, this whole pragmatic and versatile technological system, prioritizing efficiency and what works right now rather than just making the same shape over and over.
Precisely. Function over standardized form in many ways.
So thinking about that profound flexibility, What might it tell us about the hidden depths of ancient human ingenuity that maybe we're only just starting to really appreciate? And what other simplistic but not simplistic solutions might still be out there, waiting to be found in the archaeological record?